Okay. Hello everyone. Good morning, good afternoon. So this is the third part of the lecture, so lecture 3. And today I'm going to explain the integrating by parts. Okay. I did the integration for the trigonometric function and the using identities as well yesterday. So today we will go through some examples about integrating by parts. And tomorrow I will do integrating by substitution. So if you want to look at the VLE at the slides, it has everything in it, so you can have an idea or look at the book just to prepare yourself for it anyway. Right, so in this session we will learn how to integrate by parts, which is reverse for the product rule. Okay, and as usual there is some technologies problem. Yes, right. So in some integration problems, it means some integration questions, you may be asked to integrate a product. So that means two functions multiplied together, right? So for example, integration x cosine 2x dx. So these are two functions. This is one function and this is another function. Okay, both of them functions of x. So sometimes you will be asked to integrate two functions of x, for example, multiplied together. We just did yesterday, there were two functions multiplied together like sine and cosine, or sine and cosine, and we used the identities to solve it. So if you can't find something useful from whatever we learned before to solve the questions, you can use integration by parts. Or there is another kind of integration, which is the substitution. We're going to do it tomorrow. Anyway, so basically if you have two functions multiplied together and you integrate them, you use integration by parts. Let's see how it works. So the result is a little more complicated than when differentiating. So when we do the integration for a product of two functions, it's a bit more difficult than when we differentiate the two functions, okay? But they will be fine, don't worry. This is the formula you're gonna use to, this one is the formula you will use for integration by parts, which is in another word you can say it is the integration for u v dash equals uv minus integration v du, which is v u dash. Okay, but to be honest, I prefer it this way, so at least you will remember this as a video. Yeah, VDU, it's a video. Okay, to remember it, just a way for you to remember. Okay, so for example here we have x multiplied by cosine 2x dx. So what we're going to do, one of them will say, let, for example here, x equals, let u equals x and dv is cosine 2x, because this formula here is u dv, as you can see, u and dv. So u dot dv, integration of u dot dv equals u multiplied by v minus the integration of v du. Okay, so if we make x is u, then cosine 2x is going to be dv. And then now we can apply this formula. So this is going to be u, we'll say let u equals x, yeah, then du What's the derivative of x? It's 1. Yeah, and let's say v equals, well, dv is from the question, which is cosine 2x. Okay, that's too close here. Bye. Okay, and let's say dv is cosine 2x. Therefore, v is going to be the integration of cosine 2x. What's the integration of cosine? The integration of the cosine, yeah, is sine. So it's sine 2x divided by 2, which is the coefficient of x, or the derivative of x, the 2x. Okay? Remember we did yesterday sine x cosine x minus sine x minus cosine x and then sine x, and we say about the integration, it's from down there below until you reach at the top. This is the integration of dx. So the integration for the cosine here is sine. Anyway, so now the rule saying uv, so this is u times v minus u integration of v, du. Okay, so the integration of x cosine 2x dx equals uv minus integration of v du. So the u is x and v is sine 2x over 2, so that's x sine 2x over 2, that's uv, minus integration of v, which is sine 2x over 2, that's v, du is 1, yeah, dx. And now this is going to be x sine 2x over 2. We can take the minus half outside, yeah, minus 1 over 2. And what's the integration of the sine? Integration of sine is from the bottom here to the top, so it is minus cosine. So this is going to be minus cosine, like multiplied by minus cosine 2x, okay, divided by the derivative of 2x, which is 2. So this is minus half times this, which is plus 1 over 4 in that case, yeah? So the final answer is going to be, I'll just change the color so you don't mix up, is going to be x sine 2x over 2 plus 1 over 4 cosine 2x. Okay, and that's it. Yeah. So that's the way I just explain it to you now here. I'm just going to go through the slides to show you, and hopefully you will be able to recognize what's happening here. So this is the formula, u dv equals uv minus v du. This is the u, yeah, and this is dv. Okay, so let's u equals x, dv over dx is cosine 2x. Now, to find du, we need to derive x and differentiate x, and to find v, we need to integrate dv over dx. Yeah, to find v, we need to integrate dv over dx. Okay. Oh, technology. Right. So, u is x, dv over dx, we said that. Then du over dx is 1. And v is, the integration of the cosine is sine 2x divided by the derivative of 2x, which is 2, so it's half sine 2x. So now we need uv minus v du. So u times v minus the integration of u dv. Okay, ta-da! So that's uv here. What's the u? Is x, and the v is sine 2x over 2. So this is uv minus integration of the v here, which is half sine 2x, and du is 1. Okay, and it's dx here, but in both sides it's dx anyway. So you don't need to worry about it, just make sure it's there. Right, now we just tidy up. So that's 1/2 x sine 2x plus 1/4 cosine 2x, as I showed you in the slides. Hey, what's this? It's the wrong direction. Anyway, it's gone. Like I showed you here. So it's 1/4 cosine 2x. Okay. So the question here was, what was it? X cosine 2x. X cosine 2x. So this is the same question really. Why they put it twice in the slides, I don't know. Mistake as usual. All right, so there you go. You can just test yourself, like you know how to do this. And plus c at the end. Yeah, I didn't put the c at the end. I should put that really, because there is no limits. So plus c plus c, right? Oh, come on. Right. So that was same example, just maybe they put it all together, all the steps together. They showed you the u, du over dx, then dv and v, and they put it as uv here, minus integration of v du, and plus c. Okay, this is finished. So this is one example here. I can work out some other example for you, but let me see. Okay, so as I explained this question already, and so now you know, like integration by parts. We use integration by parts when you have a product of two functions of x, or a product of two functions, and we let one of them equals u, and the other one will be dv over dx. So you follow the formula for it, which is the integration of u dv equals uv minus integration v du. Okay, I'm just going to write down some notes for you maybe on the board, and so integration by parts. That's the beginning, not a good beginning. Right, so let's see here. Integration by parts. You can find this in your book, page 357, and this is chapter 23. okay, from your book. So if you have, I'm just going to write it down for you here. If you have a product, that means like multiplication, yeah? Multiplication of two functions. So if you have a product to integrate, so if you have a product to integrate, then but you can't use, you can't use any of the methods you have learned before. You can't use any of the methods which you have learned before, then you can use integration by parts to solve the question by using the formula, which is integration of UDV. Just a minute. Using the formula, which is integration of UdV over dx times dx equals uv minus integration of v du over dx multiplied by dx. Okay, this is the formula. Okay, another thing I'm going to write here. So the formula, as I said, the formula for integrating by parts is u dv over dx divided by dx equals uv minus integration v du over dx dx, or if you want, it's integration of uv dash equals uv, yeah, minus integration of v u dash. Right, the hardest bit in this case, is deciding which one is u and which one is dv over dx. Okay, so the hardest bit is deciding which one is u and which one is dv over dx. This is the hardest bit basically. So what we do is we try always to choose the one which is easy to differentiate. So for example, if we have x in the integration, it's easy to differentiate x because the derivative of x is 1. So in that case, we will say let u equals x, because du is going to be easy. So we just try to make it easier. So always to choose the one easy, always to choose the one easy to differentiate as u. So the one you see it easy to differentiate, make it equals u. Okay? So if you have x, for example, let that to be u equals x. So if you have x, let that u equals x, because du over dx is 1. Du over dx equals 1. So it won't make mess in our question. Okay. Another thing I want to say about integrating the len. I'll just use another board. Okay. Again, you can find about it in page 358 from your book. Yeah. It's about the len. So good writing here. It's not writing. Okay. We can integrate len x using the integration by parts, using integration by parts. Okay. I will explain that, but anyway, to find this, you can find it in read it in your book, page 358. Okay. So what they are saying about the len, to integrate the len, there is a trick. Integrating the len itself, it's a trick by itself. I'm just going to read what's in your book here about the len. Right? So that's page 358. Until now, you haven't been able to integrate len x, but integration by parts gives you a way to get around this. So the trick is to write len x as 1 times len x. So usually to integrate len x just like that, yeah, it's not easy. So the trick of that, we can write this, so len x dx, we can write this as, this is, they said, the trick, we write it as 1, yeah, times len x dx. So in this case, we can use integration by part, and we can say, excuse me, we can take this as u, yeah, and the one is dv over dx. So now we have, it's like we have two functions now. All right, this is the trick of it. So in that case, to solve it, we will say let u equals len x, and therefore, well, I don't have enough space here. Okay, I'll write it down there. So let u equals len x, and du over dx is 1 over x. and let's dv, what's dv? dv over dx is 1, and therefore v equals the integration of 1, yeah, which is x. Right, and now we can apply the formula. Okay, so now we can apply the formula, which is equal uv minus integration v du. So this will be, what's the u? U is ln x and v is x, yeah? So multiply them together. So that's x ln x minus integration, what's the v? Is x, and du is 1 over x. So minus v du, minus v du. So that's the v is x and du is 1 over x. So that means basically x over x, which is 1 dx. Okay? So this is gonna be right. Right, so this will be equals x ln x minus, well, basically this means 1, yeah? So what's the integration for 1 dx is x. So it's minus x dx, okay? And sorry, there's no dx, so there's no dx, sorry, because we already finished integration, yeah? So minus x plus c, that's what I meant. Plus c. And that's the answer. So it's x ln x minus x plus c. If you want, you take the x outside and you say it's ln x minus 1 plus c. Ta-da! Oh, yeah, no. Okay. No space to write anything, you know. Okay, that's it. Okay, so that's finished about the ln. I hope you understood this. Okay, let's go back to the slides. Ta-da! Okay. Right. Sometimes you will have some integration that might require to use integration by part twice. Yani we do integration by part and we will see there is another integration inside our solution need to be done by parts. Okay, so let's see if there is example here. Yes, there is. Okay, so we have this question is x squared, integration of x squared e to the power x dx. There is an example in your book as well. Repeated use of integration by parts, yeah, page 359 with limits, with the definite, but it's the same idea like repeating integration. Anyway, I'll just go through this, excuse me, I'll just go through this example here. So we have x squared e to the power x dx. So this is one function here, and this is another function here. So these are two functions multiplied together, dx, right? One of them will make it equal u, and the other will make it dv. So that's u is x squared, then e to the power x is going to be the dv. What's the derivative of x squared, which is du? Yeah, it's 2x. What's the integration of e to the power x? Integration of e to the power x equals e to the power x, same as it is. So that's why we got v from integration, the derivative. Okay, let's take this away. Okay, Now we will apply the rule, yeah, to solve this question. The rule is saying the integration of u dv equals uv minus v du, minus integration of v du. Okay, so we'll say the integration of x squared e to the power x dx equals, what's the uv? Yeah, this times this, which is x squared e to the power x minus integration of v du, which is, so v times du, which is e to the power x times 2x, yani 2x e to the power x dx. Okay, and this is gonna be x squared e to the power x minus, right, as you can see here, this is the another integration by parts inside our solution. Yeah, so we can see we have this integration and it has this function and this is another function here, right? So what we will do for this one, yeah, write it in green here, like integration 2x e to the power x dx will make one of them is u and one of them is dv. Okay, so u equals 2x, du equal du over dx is 2, and dv over dx is e to the power x, and v equals e to the power x. Okay, so this integration here is going to become as uv minus v du minus integration v du. So this will be 2x e to the power x minus integration v du. What's the du? Is 2. So minus integration 2 e to the power x dx. And this is going to be 2x e to the power x. The integration of e to the power x is e to the power x. So it's minus 2 e to the power x plus c. Okay. All this for this orange part. So this is the answer for this orange part here. For this is the answer for this. Okay, so I'm gonna rewrite it again. So this equals then, yeah, if we call this integration I can say I equals, like, let's say, let's call it I, equals x squared e to the power x, yeah, which is this one, right? Then minus all this green thing, so it's minus 2x e to the power x, then minus times minus is plus 2 e to the power x plus c. Okay, anything to tidy up? I think, well, let's check here. So x squared e to the power x so x squared e to the power x, we can take the 2 outside, Actually, yeah, 2. We can take the e to the power x as well. X plus 1. Let's see. Yeah, same thing. Okay, I'll just go over this with you step by step, and then I'll finish from this example. Yeah, so as we said, this is to start with, from the beginning, this is x squared is u, and du over dx is 2x. As you can see them here. Then this is u v minus integration v du. And we end up with 2 functions here. That's one, and that's another one. So this integration now need to be integrated by parts. So as you can see here, this now is here. They are dealing with it to integrate it by parts. So they make it as 2x e to the power x minus the v du. And the result of it was this, 2xe. This is the result of it, tx e to the power x minus 2e to the power x. So now they will join this with this part at the beginning. Ta-da! So that means the original question, which is this, equals what? Equal, which color? Yellow, let's say, equals this part, which is this one here, minus, instead of this integration, which color I did the integration? Today, yeah, okay, turquoise here. So, yeah, so minus this, which is this one here, which is this one here. Okay, and this part is the yellow. I hope you understood, right? You just, it's easy, just follow step by step, you'll be absolutely fine. Right. No, substitution, I will do it tomorrow. Right, so that's done. Integration by parts. I went over the slides, which is relating to this. I will do some questions for you as well. What is it? Which question? Also, you can look at the book if you want. Right, I'm just going to do some questions about integration by parts. So here, let's say, find the integration of, let's see what's there. X squared ln x dx. Okay, this is not from your book, just from another book. So how we have 2 functions here, x squared and ln x. Yes? Say yes. So this is one and this is another one. So we can use ln x, take it always as u, because it's easy to differentiate. It's not easy to integrate ln x, so it's easy to differentiate ln x. So let's say u equals ln x. That u equals ln x, then du over dx is 1 over x, and dv over dx is the other function, which is x squared. Therefore v is the integration of the x squared, which is, remember, when we integrate, the general rule, yeah, is if you are integrating x to the power n dx, it's going to be x to the power n plus 1 divided by the new power, which is n plus 1. Yes? Yes. So in this case, the integration for x squared is going to be x cubed divided by 3. Okay, so now we have them all. We apply the rule saying uv, yeah, so u times v minus v du. So minus, so u times v minus v du. Okay. So let's say this integration equals I. Let x squared ln x dx equals I. So instead of keep writing integration of this, I can just write I equals uv minus integration v du over dx. Okay. So uv is x cubed ln x over 3, that's uv, minus integration of v, which is x cubed over 3, du is 1 over x, yeah? So it is basically like x cubed divided by 3x. So x cubed over 3x dx. Yes, yes, yes. Do you want me to write it in details? Maybe just a minute. I can write it different way just for you to understand why. So we can write it as x cubed over 3 times 1 over x dx. Okay? So now this means x cubed ln x over 3 minus integration of x squared over 3. Why x squared? Because we cancel this x with one of those here. So we left with x squared. Okay? So we got x squared over 3 dx. Okay. So the final answer for this is going to be x cubed ln x. Oops. Doesn't work, this part of the board. Okay. Change the color, hopefully you will understand. Yeah. Okay, so I'll just write it next to it because this part of the board it won't let me to write really. Right, so this equals x cubed ln x over 3 minus the integration of x squared over 3 is x cubed, yeah, it's going to be, so the integration of x squared is x cubed divided by 3, so it's 3 times, and we already have a 3 there, so it's 9 plus c, and that's it. Okay, the end for this example. Right, let's see this question. I think we did this already. Yes. Yeah, this is about ln x with limits. I'll do this as well for you. this integration but with limits. So evaluate the integration from 1 to 2, yeah, ln x dx, leaving your answer in terms of natural logarithms, so I leave it as a ln. Okay, so in this one here, as we said, let I equals the integration from 1 to 2 then x dx. Okay, and as I told you earlier, we have the trick with the ln to be able to solve it by parts. We make it ln x times 1. So this equals the integration from 1 to 2 ln x, yeah, times 1 times 1. This is not x, this is times, so just make it like that if you want, dx, right? So now I can say one of them is u, one of them is dv. Which one is the u? The ln x is u and 1 is dv, right? So u equals ln x, then du over dx equals 1 over x, and dv over dx is 1, therefore v equals x. Then to apply the rule, we multiply them this way, uv minus v du, v du. Okay, so I equals uv, which is x ln x, minus integration of x du, which is 1 over x multiplied by 1 over x dx, which is 1, yeah? So this equals x ln x minus integration of 1, which is x. Oh, I forgot we have limits here. 1 to 2, right? When we have limits, we need to apply the limits on the uv as well. It's good that I remembered to tell you. We need to apply the limits on the uv as well, right? So minus the integration for x dot, or multiply by 1 over x dx. And this is going to be, I don't think the board will be enough, really. Don't have enough space. So this is going to be, now we'll substitute the value of, start from the 2 first, yeah? So instead of each x, I'll put 2. So this is going to be 2 ln 2 minus 1 ln 1. That's the first part done. Okay, minus the integration of 1 is x. Then there's going to be integration of 1 over x is ln x, so it's going to be 1 ln x, yeah, so it's going to be minus 1 ln x from 1 to 2. So this is 2 ln 2. Ln 1 is 0, so there's going to be 0, because 0 times 1 is 0. Right? So it's 2 ln 2 minus 1 sorry, it's not ln x, yeah. Minus, actually, sorry, I have a mistake here. It's minus x, not ln x. That ln x mixed up with the step before. Okay, so minus x from 1 to 2. So that means 2 minus 1, which is 1. So 2 ln 2 minus 2 minus 1. Yeah, and this will be equal to 2 ln 2. Then minus 2 minus 2 plus 1 is minus 1. And that's it. No, smiley face? Smiley face, come on. Right. This is the answer for it. So I equals this. Okay? I hope you benefit from this. The last thing just to write it down for you is this integration with the definite integrals by parts. So definite integral by parts, use the formula, which is if you have integration from a to b, these are the limit for u dv over dx equals the uv, but you apply the limit to it. So from a to b minus the integration from a to b for v du over dx. Yeah, that's important. If you have limit and you're doing integration by parts, you need to apply the limits on your uv term as well. Okay, both of them. And that's it. Right, so you have some work to do as homework. I want you to do. So that's on exercise 10.1, page 358. Okay, and 10.2, page 359, and 10.3, which is page 360. Okay, so I want you to do the questions about integration by part. All right, let's see what else I want you to do. Okay, so I want you to do an exercise 10.2, question 1, B and C. B and C. Question 2, I want you to do A, C, A and C, and exercise 10.3. Did I told you about the exercise 10.1? No? Okay. Exercise 10.1. This is page 358. And the answers on page in your book, basically, 539. Okay? Just to make life easier for you to check your work is correct or not. So exercise 10.1, you do question 1, A, B, C, D, all of them yani, A, B, C and D. And you do question 2, and you do question 3, and question 4, A and B. A and B only. Okay? What else? I gave you 10.1, 10.2. Anything else? I think yes, 10.3. Use integration by parts twice. Yeah, this is a nice one. You will enjoy it. So exercise 10.3. Do question 1. Change the color. Exercise 10.3. Question 1. Enjoy A, B, C, D. A, B, C, D. And then that's it. I think. I hope so. Yes, I think that's enough. And if you're happy and you know it, solve the questions. Take care, and I'll see you later in the lecture. All right? So prepare for this, and if you have any questions, send it to me, and if I can, I can help you with it. All right? Take care. Bye.